Welcome to my project bazaar.com. Let me discuss about the project lesion detection and characterization with context-driven approximation in thoracic FTG PET CT images of NSCLC studies. Let me discuss about the abstract of the project. The major problems encountered are image segmentation and perfect system response function. Image segmentation is defined as the process of classifying the voxels of an image into a set of distinct classes. The difficulty in PET image segmentation is compounded by a low spatial resolution and high noise characteristics of PET images. Despite the difficulties and known limitations, several image segmentation approaches have been proposed and used in the clinical setting, including thresholding, edge detection, region growing, clustering, stochastic models, deformable models, classifiers, and several other approaches. The strategies followed for validation and comparative assessment of various PET segmentation approaches are described. Future opportunities and the current challenges facing the adaptation of PET guided delineation of target volumes and its role in basic and clinical researches are also addressed. Small lesions is only 2 or 3 voxels in diameter and of marginal contrast. It could easily be missed by human observers. Our method aims to provide radiologists with a map of potential lesions for decisions so that the diagnostic efficiency can be improved. It utilizes both PET and CT images. The CT image provides a lung mask to which lesion detection is confirmed, whereas the PET image provides distribution of glucose metabolism according to which lung lesions are detected. Experimental results show that the respiratory motion correction significantly increases the success of lesion detections, especially for small lesions, and most of the lung lesions can be detected by our method. The method can serve as a useful computer-aided image analysis tool to help radiologists read images and find malignant lung lesions. Let me discuss about the flow diagram for our process. First, capture the input image from source file by using UA-getFile and imRead function. User can able to change the size of the image by providing pixel height and width with the help of imresize function. Next, Gaussian filter is windowed filter of linear class. By its nature is window weighted mean. Motion filter is the apparent streaking of the rapidly moving objects. Next, in the lesion detections, patch-based detection approach are proposed, where in this model initially a basic sparse representation approach can be applied to the labeling problem. Next, approximation with a region label contest has been applied, where extracted reference patches that are visually similar should contribute similarly to the approximation. In spatial consistency, constraint is to encode the spatial consistency preferences into the labeling phase. Finally, in lesion detection, patch-based detection has been performed. Label the patches into LF, MS or LS categories. The LS patches would be the lesions detected. Next, in the lesion characterization, where object-based characterization are approached. In the object-based characterization modules, features has been characterized LT, LN and MC. Simple spatial features are then computed for the detected lesions, and the lesions is characterized to LT, LN or MC. Here, approximation with image level context is approximated by a weighted combination of multiple other images. This is based on the observation that there are great similarity in the normal anatomical appearances between images. In the appearance constraint and similarity constraint improved the multi-atlas model, which is used to distinguish the lung tumor and abnormal lymph nodes. Finally, object-based characterization estimated the lung fields and mediastinum with the reference images. Finally, the performance are calculated. The accuracy, sensitivity and specificity of the classifier is measured. The accuracy represents the efficiency of the process. The sensitivity shows how the algorithm gives correct classification. Specificity shows how the algorithm rejects the wrongly classification results. We design a spatial consistency constraint in a graphical model to improve the detection performance. Our Lesion characterization method is based on multi-atlas approach. We have proved the appearance constraint for better structure estimation and lower method complexity without the additional structure delineation step. We also design a simple rule-based algorithm to label lung tumors and abnormal lymph nodes, replacing the more complex SVM classification and more heuristic post-processing. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click the file and run for executing this process. This is the main window of the lesion detection and characterization. By pressing the CT image button, we can browse the CT image from the dataset folder. Select any one images from the dataset folder. Here I display the CT image. For PET image is not available, so here I didn't use the PET image. Here I use the saliency map of our CT image. By pressing the PET image, the corresponding saliency map result will be obtained. I displayed this PET saliency map result in an access to plot. By pressing the input image button, we can combine the CT and PET result. Here I display the input image. By pressing the lesion detection, we perform the detection of lesions. Here we need to enter the threshold value, that is seed value. For segmentation process, we need to enter the seed value within the range of 0.5 to 0.7. By pressing the OK button, we can segment the lesions. This is the binary representation of our input image, and this is the color image for our lesion detector portion. This is the lesion detector for lung region and also mediastinum. Next, this is the lesion characterization window, that is feature extraction window. By pressing the detected feature button, we can extract the features by using the K-means algorithm. Also using this is the feature values which I have extracted from the test image. Next, by pressing the lesion characterization button, we can characterize our input image into abnormal lymph nodes or primary lung tumor based on the feature values. By pressing the performance analysis button, we can got the analysis graph for accuracy between existing and proposed, and the sensitivity for existing and proposed, and plot of specificity for existing and proposed. A context driven calculation method to estimate between lesions and soft tissue and among lung tumors and atypical lymph nodes. Thank you.